Hey guys, this is from topic word problem involving optimizing area by quadratic function, by using a quadratic function. So what we have here is Greg wants to build a fence for his rectangular garden. He has 440 meters of fencing. Suppose that a side length in meters of the garden is X, and they have the X. Let me change my color if I can do that. They have X right here. That's one side as shown. So part A is asking us to find a function that gives the area A of X of the garden in square meters in terms of X. Okay, so let's start with what we know. We know that we find the area of a function by multiplying, we might say, base times height. Okay, so what I know in this case is that my height is X. I need to know the length of my base. So that's step one. We need to find that. So let's break this down. We need to take it back to geometry, and let's think about our properties that we have that relates to rectangles. And what we know with rectangles is that opposite sides are congruent. That means that opposite sides are equal. So what that tells me, what that also means, is that if this one side over here is X, then the other side is X. Okay? So here's what I know then. I know that this piece and this piece, right, all of that is left measures to be the total amount minus the two pieces on the end. So minus 2x. Okay? So that is the lengths of the remaining sides of the rectangle, because we began with 440 meters and we've utilized 2x units or 2x meters for the heights of the side. So this right here represents the remaining length that we would use to represent the base, the length of the base and the length of the top up there. So, but what I need is just the length of one of those sides. So then what I would do is divide that by 2. So what we have is that 220 minus x, that represents, let me find my eraser, that represents now the length of the base, 220 minus x, and the length of the height. So let's go back to part A. It's asking me to find the area of the function that represents this rectangle. So again, it's base times height. So the base of this thing is equal to 220 minus x, and the height is x. So if I multiply this out, let's use my distributive property, that gives me 220x minus x squared. Okay. Part B. What side length x gives the maximum area that the garden can have? So once you get to this part here, this topic, you've had a number of topics prior to this, and I think one of them relates to finding the vertex, the max and the min. And so there's a number of ways that we can find our vertex using algebra, but what I would use is the formula that we have for our vertex. So the equation for my axis of symmetry and is the opposite of b over 2a. So let me take a moment to explain this. So if I have a quadratic, what we know is that we have some vertex, right? And that vertex falls along my axis of symmetry. So I really haven't read all the notes, but this is how I always teach it. So what I'm getting at is if you can find that axis of symmetry, and the way we find that axis of symmetry again is the opposite of b over 2a. That is that gives you an equation for a vertical line that is our axis of symmetry. But if we can find that equation, we also know the x coordinate for where my vertex occurs. Okay, so the only thing I need to do here for this equation, let me bring it down where I have some room. What I have here is that a of x is equal to 220x minus x squared. I would recommend that we write this in descending order. So that is a negative x squared plus 220x, and there's really a plus 0 on the end. So what I'm getting at is that my a is equal to -1 and my b is equal to 220, and in this case, because there's nothing on the end, I have c is equal to 0. But what I'm looking for is my axis of symmetry, and that is x equals the opposite of b. So the opposite of b would be -220 over 2 times my a. So that is -220 divided by -2, and that gives me 110. So it's asking me at what side length x gives the maximum area. So what we did here, and I should probably back up, what I did, you can imagine that if you graph this, that function represents possible areas that that rectangle would have in relation to the length of x. So what we found was a vertex. We found the maximum area, and we found that it occurred when x equals 110. Okay, so part C is saying what is the maximum area that the garden can have. So the last piece here, and if you need to pause, please pause. That's fine, but I'm going to erase this. So the last piece that we have here is asking me to find, and I would just leave this piece here, is asking me to find what the actual area is. Find the area when x is at its maximum, or when you're at that vertex. So we found the vertex to occur when x equals 110. So we would substitute that 110 into our function. And if we do that, what we get then is 24,200 minus, oops, my pen, minus 12,100. And when we simplify that, that gives us 12,100. So what we found, so I could say, so, ... the maximum area is, let's move this up, 12,100 meters, square meters. And I could say when, and I could pause and maybe, let's put it in parentheses, and I could say that that's when x is equal to 110. All right, so I did that fairly quickly, but you guys can pause it, stop, rewind, and ask questions as needed. And if you guys have any other questions, again, please don't hesitate to